Hello everyone, this is Project Warden submitting for Hackathon Galactica. So right now AI agents can hold your wallet. It can actually spend real money without asking. So what's stopping them from draining everything? So this is where Warden comes in. It's basically a firewall for AI agent. It enforces spending policies in two phases. One is off-chain in TypeScript and another one is on-chain using EIP 7702. So even if an agent gets compromised, it can't blow past its limits. So right now, giving in if you giving an AI agent a wallet, that means trusting it completely. There's no spending cap, no anomaly detection, no way to shut it down. One bad prompt injection and the funds are gone. So Warden fixes this in two phases. The first layer is basically a TypeScript policy engine. It checks every transaction in under a millisecond, 19 rules, and 8-factor risk scoring anomaly detection. And the second is basically a Solidity smart contract on Sepolia using EIP 7702. This can be deployed to any of the supported chains by USDT. The agent's wallet delegates to our policy delegate contract. This is basically these are on-chain limits, so the agent can't get around them even with a full key access. So let's try to run Warden, and let's see. Here we can see we have pre-deployed agents where you can actually test your scenarios, and also we have deployed actually published packages in npm that you can use. So this is our policy engine, so you can use this is basically a secondary layer on top of wdk, or you can basically use our MCP server. So you can use this MCP server. If you don't want to use, you can basically use this in your OpenClaw also, and you just have to add your RPC URL and the token address which you want to actually control. So let's see this in demo. So this is my OpenClaw agent that I've deployed. So let's click on start. Okay. So I'll tell this agent to use this MCP server. Just you download and use this MCP server. And for the config, I'll use this only. Okay, use this config. Yeah. And also, if you read the documentation, you will see they are like predefined configs that you can set. So suppose cooldown period or approval USDT limit, all these things. So you can do these before creating the wallet. So there are a few aspects that you have to tell before creating the wallet. Otherwise, it will be set to the default. And other things which are normal policies that you can change during the runtime, and basically your OpenClaw agent cannot actually change it without your approval. So once it sets, then your agent cannot actually drain your wallet and go past the limit that you have set it to perform in. So I'll say use this config and use the default config. When I'll create this wallet, I'll use basically the default config here. Okay, so the config and the MCV server is set up, and now I can just create a new wallet with basically default policies that I can change later on. Okay, so the wallet is created. You can see this is the address, and I'll quickly copy this and send few USDT into this address. Okay, so I've successfully funded this wallet, and you can see I have like 0.03 ETH and 500 USDT. Now I'll run send 20. So what I'll do is I'll check current policy status. So you can see it gave me this. There are lot of other policies, more complex policies that you can create. But for this video and for this usage, I'm creating a very simple policy. So the max transaction will be 50 USDT, and daily limit is, and also the cooldown period is 30 seconds. So after every transaction, the next transaction can be sent after 30 seconds. Even if this AI agent forces it to, it cannot, because the policy engine will stop it immediately. Otherwise, the EIP 702 will disable that. So now what I'll do is I'll send 20 USDT to this address, and what I'll do is after this transaction, I'll change the policy to uh, 10 USDT max per transaction. So I'll change this to this, and it will actually call the MCP and set the policy here. So okay, it actually successfully sent that transaction, so that the transaction is done. The transaction hash is this one. If I go to so you can see the transaction actually successfully went through the transfer call that happened here to the USDT address. Now what I'll do is I'll set the transaction limit to this, and I'll again type this like send this much. Okay, so the transaction limit per transaction has been updated, and now I'll send 20 USDT. So this now this will force the agent to do a 20 USDT transaction, but it will be blocked by the policy engine, which is built on. Okay, so you can see it actually blocked the transaction here. And suppose the daily limit is do uh, set the daily limit to 50 USDT and per transaction limit to 20. After this, what I'll do is I'll say do suppose 10 transaction of 20 US, suppose 10 USDT to this address. Okay, so this is, I'm just like giving you a scenario here, but this can be used in trading protocols also. So suppose your bot is actually trading on suppose a platform, then you can set more complex configs to actually protect your wallet from actually going zero. Okay, so the max limit is updated. Now I'll do 10 transaction of $10, which will go through. So basically 5 transaction will go through, and the sixth one will be blocked by the policy engine. And you can also click on show audit. Okay, so now here you can see all the like 3 transaction are done, because like we already did 2 transaction of $10. But rest the 4 to 10 transaction are blocked by the policy engine. So this is how basically you'll get easily protected by if your agent misuses your wallet, or something goes wrong, you are still safe. You are actually still safe from draining your wallet. And this project is basically, everyone is talking about we are creating network of agents, network of e-commerce of agents. But the thing is, when you are creating e-commerce for agents using WDK and all these things, you need to have this policy engine um as your layer integrated into your system, into your agents and your swarm of agents. And I think this will be a very useful and one of the key important things while creating agents and agent economy. Thank you.